Hello children. Today we are going to start a new chapter from your 10th standard science book Unit 4 Electricity. Children, do you know how important electricity? Yes, everywhere is electricity. Means that without electricity it is impossible to imagine a life. But in this chapter we are going to learn various terms used in understanding the concept of electricity and applications of electricity in day-to-day situation. Come, let's move on to the video session. Dear students, today we are going to learn Unit 4 Electricity. In this lesson, you will learn various terms used in understanding the concept of electricity, and we also learn the importance of the applications of electricity in day-to-day situations. Dear students, before enter into the session, we have to know what is electric current. This electric current is always compared with water flow. Imagine a tank full of water attached with pipe. If the motor is not attached, the water will flow through a pipe? No, because water and pipe are in the same height. After we attach motor to it, the pipe allows the water. Why? Because motor gives a pressure on the water. So the pipe allows the water to it. In similar manner, in a circuit we have battery, that is motor, we have wire, that is pipe, and water is the electron flow through a what pipe. So can you say how the current flow? When you switch on in the battery, they produce a pressure from positive terminal, that means higher electric potential, to negative terminal, lower electric potential. This what actually happens in the circuit. Like that, overhead tanks in our houses, in that case also water will gone through because the gravity will pull the water down. Okay, in the similar manner, a electric current passes from the positive terminal, higher electric potential of a battery, to the negative terminal, lower potential energy, through a wire. Now let's see the definition of electric current. Electric current is often termed as current and it is represented by the symbol I. It is defined as the rate of flow of charges in a conductor. This means that the electric current represents the amount of charges flowing in any cross section of conductor in unit time. For example, Q is the charge that passes through any cross section of conductor in time t. Okay, so then the current flowing through the conductor is what? I is equal to Q by T. I is the current and Q is the charges flowing per time, per unit time. Electric current is represent the amount of charges flowing in any cross section of a conductor. SI unit of electric current. The SI unit of electric current is ampere. It is denoted as A. The current flowing through a conductor is said to be 1 ampere when a charge of 1 coulomb flows across any cross section of a conductor in 1 second. Hence, 1 ampere is equal to 1 coulomb by 1 second. What is coulomb? It is the unit of electric charge in the meter, kilogram, second, ampere system. The basic unit of SI system of physical unit, it is abbreviated as C. The coulomb is defined as the quantity of electricity transported in 1 second by a current of 1 ampere. It is approximately equivalent to 6.24 into 10 to the power 18 electrons. Let's solve the problem number 1. A charge of 12 coulomb flows through a bulb in 5 seconds. What is the current through the bulb? So here 12 coulomb is the unit of electric charge. So wherever you're seeing the coulomb, that is the unit of electric charge, so we can take Q is equal to 12 coulomb. Okay, Q is the charge symbol. Okay, so what is the time here? 5 second. Okay, so what do you want to find here? What is the current through the bulb? For 5 seconds, there is a flow of 12 coulomb of charges, means what is the current that we want to find? So we know that charge and time. So what do you want to find? Current. So we already know the formula to find the current, that is I is equal to Q by T. So what is Q? That is charge. We know that 12 coulomb. And what is time? 5 seconds. That also we know that. Just substitute these two values. You know that. Okay. So when you divided these two, what you'll get? 2.4 ampere. So ampere is the unit of current. Okay. So I is equal to 2.4 ampere. So what is the current through the bulb? 2.4 ampere is the current passes through the bulb. Next topic we are going to see is that electric circuit. Electric circuit is a closed conducting loop consists of electric components through which electrons are able to flow. This loop is made up of electrical wire to connect battery and electric appliance. Okay, if you take a simple circuit, there will be a bulb, battery and key. Okay, if you open the circuit by using key, that means we are disconnecting the circuit. So the bulb will not glow. Why? Because there is no flow of current. If you close the circuit by using switch or key, that means there is a flow of what? Current. So the bulb will starts glowing. This is the simple circuit of electric current. Okay, so in the circuit, if the switch is on, the bulb will glow. If the switch is off, the bulb will not glow. Why? Because we know that already. The circuit must be closed in order that the current passes through it. The potential difference required for the flow of charge is provided by the battery. The electrons flow from the negative terminal to the positive terminal of the battery. Next, we have to understand the components that we are used in the circuit and what are the uses of components and symbol for the components. Let's see the table to understand the components why we are using in the electric circuit. Now we'll see this table. First component is that resistor. This resistor used to fix the magnitude of the current through a circuit. And the symbol is given here. When you draw the circuit, you have to draw like this. Okay. For example, you are drawing a resistor, means in the circuit diagram you have to use this symbol. Okay. Next component is that variable resistor or rheostat. This rheostat used to select the magnitude of the current through a circuit. Okay, the symbol is given here. Ammeter. Ammeter used to measure the current. Okay, the symbol is given here. And next is voltmeter. This voltmeter used to measure the potential difference. The next component is that galvanometer. This galvanometer used to indicate the direction of current. Okay, which direction the current is flowing. Okay, that will indicate this instrument. A diode has various uses which you will study in the higher class. Okay, let's see the symbol. Positive sign is anode and negative sign cathode. Next one is light emitting diode, LED. This LED has various uses. This one also will learn about this in higher study, higher classes, and let's see the symbols. Next, finally, ground connection. Okay. Ground connection used to provide protection to the electrical components. It also serves as a reference point to measure the electric potential. The symbol is given here. Let's see the example to understand the potential difference. Suppose we take two water tanks placed at the same level and fill them with water. We connect both with tube. In this case, does water flow from one tank to another? No. This is because there is no pressure. Okay, water is exact the same level in both tanks, so water will not flow. Suppose if we increase the height of one tank, does water flow from one tank to another? Yes. This is because water now flows from tank having higher pressure to tank having lower pressure. This is why tank has a higher water level, so water will flow from tank A to tank B. Hence, for flow of water, there should be difference in water pressure. Similarly, for flow of electricity, there should be difference in electric pressure. This difference in electric pressure is called what? Potential difference. So, what is electric potential? The electric potential at a point is defined as the amount of work done in moving a unit positive charge from infinity to that point against the electric force. Flow of electricity. In a battery, there is a positive and negative charge. So, where is a higher potential energy? Okay, in the battery, that is positive terminal. So, the electrons will move from positive higher potential to lower potential. What is electric potential difference? Electric potential difference between two points is defined as the amount of work to done in a moving unit positive charge from one point to another point against the electric force. Suppose if you move a charge q from the point B to point A, let W be the work done to move the charge from A to B. So, what is the potential difference? The potential difference that is denoted by V is equal to work done by charge. Here, work done is denoted as W and charge we know already Q. Okay. So, now we know that what is potential difference and unit of potential difference. Unit of potential difference is what? Volt. So now what is volt? The SI unit of electric potential or potential difference is called what? Volt. It is denoted as V. The potential difference between 2 points in 1 volt, if 1 joule of work is done in moving 1 coulomb of charge from one point to another against the electric force. So how you will write 1 volt is equal to 1 joule of work done in moving a 1 coulomb of charge from one point. 1 volt is equal to 1 joule by 1 coulomb. That is called what? Volt. Students, do you know which instrument is used to measure this potential difference? That is voltmeter. Voltmeter is an instrument. It is used to measure the potential difference. Let's solve the problem number 2. The work done in moving a charge of 10 coulomb across 2 points in a circuit is 100 joule. What is the potential difference between the points? So here we want to find the potential difference between the points. Now we know that charge and joule, okay, that is work done. Okay, so charge q is equal to 10 coulomb is given here and work done W is equal to 100 joule also given here. Now we have to find potential difference. So you know that potential difference formula V is equal to W by Q. So what is work then? 100. And what is charge? 10 coulomb. So when you divide these two, what you will get? Potential difference V is equal to 10 volt. We'll see the topic of Ohm's law. A German physicist, Georg Simon Ohm, published the relation between the potential difference and current, which is known as Ohm's law. This relation can be understood from the following activity. According to Ohm's law, at constant temperature, the steady current I flowing through a conductor is directly proportional to the potential difference V between the two ends of the conductor. Okay, here the temperature is constant. Okay, when the temperature is constant, the current is what is directly proportional to the potential difference. It means when the current is increases, the potential difference also increases. When the current is decreases, the potential difference also decreases. That is the meaning for I is flowing through a conductor, that is I is current, is directly proportional to the potential difference V. Okay, let's see the mathematical way, the Ohm's law. Here, current is directly proportional to potential difference. Hence, 1 by V is equal to constant. The value of this proportionality constant is found to be 1 by R. So, to remove the proportionality, we are adding the constants, that is 1 by R. So, we will get therefore I is equal to 1 by R into V. Finally, we'll get V is equal to IR. So here R is a constant for a given material, that is say nichrome, at a given temperature and is known as resistance of the material. The potential difference is V. It is proportional to the current I. Here the graph is graph between V and I is a straight line for a conductor. Okay, that is shown in the figure. So why we are getting this straight line means when the current is increases, the potential difference also increases. Okay, so here Ohm's law says that, proving that when at the steady temperature, the current high is directly proportional to the potential difference. So when current increases, the potential difference also increases, so that there is a steady current flowing in the conductor. Okay, this is what Ohm's law. Now we'll see the problem 3. Calculate the resistance of a conductor through which a current of 2 ampere passes when the potential difference between its ends is 30 volt. Okay, what do you want to calculate? Resistance of a conductor through which a current of 2 ampere passes. In a conductor, 2 ampere of current is passes through. Okay, its potential difference between that ends is called what? 30 volt. So what do you want to calculate? Resistance. Okay, so current through the conductor I is equal to what? 2 ampere. Okay, and then potential difference is what? 30 volt. Okay, you know that current is denoted as I, its unit A, and potential difference is denoted as V, its unit is what? Volt V. So we know potential difference, current. What do you want to find? Resistance. From Ohm's law, what is the Ohm's law formula? V is equal to IR. Okay, so we know that potential difference I. What do you want to find? R. So R, you just keep this side. Okay, and so we'll get the formula V by I. So what is V? 30 and I is 2. When you divide these two, what you'll get? 15. Okay, so resistance is what? 15 ohm. Resistance unit is what? Ohm. Okay, so R is equal to 15 ohm. So resistance is what? 15 ohm. You must have had electric shocks, haven't you? Did you get the shock on a plastic wire? It is not possible. You can't get shocks from plastic wires, but why is it so? It is because of a phenomena of resistivity. Let's read the resistivity of various materials. Before that, we have to know what is resistance. We know that electric current that flows in a circuit is similar to the water flowing through a river. In a river, rock, branches, and other particles resist the flow of water in a very similar fashion. A circuit has element to resist the flow of currents. Resistance is nothing but this property of resisting the flow of electrons or the current. The unit of resistance is ohm. 1 ohm is equal to volt per ampere from Ohm's law. We have seen that R is equal to V by I. So here where V is the voltage and I is the current and R is the resistance. Dear children, do you know why we are using resistors in a electric circuit? These resistors are used to resist or control the flow of electrons by the conductive material. They do not provide any power to the circuit. They may reduce the voltage and current passing through the circuit. Hence, resistors are passive devices. Most of the resistor are made up of carbon, metal or metal oxide film. So, what is resistivity? Resistivity is the resistance per unit length and cross sectional area. It is the property of the material that opposes the flow of charge or the flow of electric current. The unit of resistivity is ohm meter. So, we can verify by doing an experiment that the resistance of any conductor R is directly proportional to the length of conductor L and is inversely proportional to its area of cross section A. In this image, imagine that there is a coil of wire. Okay, its length is what? L. Okay, its area of cross section is A. Its resistivity is what? Rho. Okay, so resistance is what? R. So first what they saying, R is directly proportional to length of conductor. So R is directly proportional to length. Okay, and it's inversely proportional to what? Area of cross section. So R is inversely proportional to area. So when you combine these two, we will get R is directly proportional to L by R is inversely proportional to area. So R is equal to rho L by A. Here rho is the what? Resistivity. Okay. So to remove the proportionality, we are adding constant, that is called what? Resistivity. R is equal to resistivity L by A. So here rho is a constant called electrical resistivity or specific resistance of the material of the conductor. Okay, from the above equation we'll get resistivity is equal to RA by L. If we substitute L is equal to 1 meter and area is equal to 1 meter square, then from the above equation we will get resistivity is equal to R. Dear students, do you know different materials have different resistivity? For example, copper and aluminium have low resistivity. Good conductors have less resistivity. Insulators have a high resistivity. The resistivity of semiconductors lies between the conductors and insulators. Gold is a good conductor of electricity and so it has low resistivity. Glass is a good insulator which does not allow the flow of electrons, hence it has a high resistivity. Silicon is a semiconductor and so it is allows partial movements of electrons. The resistivity of silicon comes between glass and gold. The resistivity for perfect conductors is 0 and the resistivity for perfect insulator is infinite. Dear children, do you know nichrome is a conductor with the highest resistivity equal to 1.5 into 10 to the power minus 6 ohm meter. Hence, it is used in making heating elements. Next topic is conductance and conductivity. Conductance of a material is the property of material to aid the flow of charges and the passage of current in it. Okay, then conductance of material, how you will write in mathematical way? Conductance is defined as a reciprocal of its resistance. So, this conductance is denoted as capital G and the reciprocal of resistance is equal to 1 by R. What is the unit of conductance? Its unit is ohm inverse. It is also represented as mho. What is conductivity? The reciprocal of resistivity of a material is called its electrical conductivity. So this conductivity symbol is what? Sigma. Okay, sigma is equal to 1 by rho. Okay, its unit is ohm inverse meter inverse. It is also represented as mho meter inverse. Copper, aluminium, etc. While some other materials are non-conductors of electric current, that is insulator, glass, wood, rubber, etc. Conductivity is more for conductors than for insulators, but the resistivity is less for conductors than for insulators. The resistivity of some commonly used materials is given in this table. Nature of the material: conductor, material, copper, nickel, chromium. Copper resistivity is 1.62 into 10 to the power minus 8. Nickel 6.84 into 10 to the power minus 8. Chromium 12.9 into 10 to the power minus 8. Insulator: glass, rubber. Glass is 10 to the power 10 to 10 to the power 14. Rubber 10 to the power 13 to 10 to the power 16. Dear students, so far you have learnt how the resistance of a conductor affects the current through a circuit. And we also studied the case of the simple electric circuit containing a single resistor. Now we are going to study about the combination of many resistors in a circuit. This combination of resistors is known as system of resistors or grouping of resistors. Resistors can be connected in various combinations. The two basic methods of joining resistors together are resistor connected in series and resistor connected in parallel. In this following session, we are going to learn about the many resistors having different resistance values or connected in series and in parallel. Resistors in series. A series circuit connects the components one after the other to form a single loop. Series circuit has only one loop through which current can pass. If the circuit is interrupted, it means disconnected at any point in the loop, no current can pass through the circuit. Okay, so if you see the circuit, electric circuit, all the resistor are connected one after other. Okay, if any resistor is disconnected, what will happen? The current will stop flowing to other end. So that is why the current will not pass through the circuit. Okay, the other resistor also will not work. So this is the resistor in series. Here we can able to see the image. If one resistor fails, whole circuit fails. Okay, see that in the second one, the bulb is what broken. Okay, so the current will not passes through other end, so that other bulb also not glowing. Okay, in the first image, there is no any problem in the circuit. Okay, there is no any disconnection, so that the bulb, both the bulb are glowing. Now let's derive the formula for resistors in series. Let three resistors R1, R2 and R3 be connected in series. Okay, so how many resistors are connected? Three resistors. Let first resistor be a R1, second resistor be a R2 and third resistor R3. Let the current flowing through them be I. We already know current is what? I. Flowing through a conductor, so I. According to Ohm's law, the potential difference is what? V1, V2 and V3 across R1, R2 and R3 respectively are given by. Okay, we already know Ohm's law. What is Ohm's law? At a steady temperature, the current is directly proportional to what? Potential difference. Okay, so we know the formula V is equal to IR. Okay, so here 3 resistor is there, so the potential difference also 3 and the current is also we have taken commonly. So potential difference V1 is equal to IR1 and V2 is equal to IR2. V3 is equal to IR3. Why? Because there is a 3 resistor connected in series. So let's take that first one, second one and third one. The sum of the potential difference across the ends of each resistor is given by, so when you add the potential difference, only potential difference, so V is common, V is equal to V1 plus V2 plus V3. Using equation 4.7, 4.8 and 4.9, we'll get B is equal to IR1 plus IR2 plus IR3. This one will take 4.10. The effective resistor in a single resistor which can replace the resistors effectively, so as to allow the same current through the electric circuit, let the effective resistance of a series combination of the resistors be Rs. So then we will get V is equal to IRs. Okay, that is 4.11. Combining equation 4.10 and 4.11, we will get IRS is equal to IR1 plus IR2 plus IR3. So here RS is equal to R1 plus R2 plus R3. That is equation number 4.12. Finally, we'll get Rs is equal to NR. What is N here? N is the resistor of equal resistance and R is the connected in series. The equivalent resistance is NR. The equivalent resistance in a series combination is greater than the highest of the individual resistance. So here you can understand that when a number of resistors are connected in series, their equivalent resistance or effective resistance is equal to the sum of the individual resistance. Resistance in parallel. A parallel circuit has two or more loops through which current can pass. If the circuit is disconnected in one loops, the current can still pass through the other loops. In the circuit we can able to see it is not like a resistor in series. Okay, we have a three connections, three loops in the same line. Okay, so if one loop is disconnected, the wire is disconnected, then the other two ways are there to current pass through. Okay, so one resistor is not works, then other two resistor will work. Why? Because there is a more than one connections. So parallel circuits, if one resistor fails, circuit still works. If you see the image 1, there is a two bulb, okay, two connections are there, okay. So the current is passes through, there is no any problem, so these two bulbs are glowing. In the second image, in the first one, the bulb is broken, so but current passes through. Because of bulb broken, the bulb is not working, okay. In the another bulb is glowing, okay. Why? Because there is a one more connection, okay. So the current is passes through in that connection, okay, and then the bulb is glowing, okay. In the next one also same, okay. So in parallel circuit, the resistor, one resistor fails, the circuit still works. Why? Because there is a more than one loop. Consider that three resistors R1, R2 and R3 are connected across two common points A and B. Okay, when you see this circuit, we can able to see there three resistors are connected in parallel in between that two points A and B. The potential difference across each resistance is the same and equal to the potential difference between A and B. So all the resistor having the same potential difference in between that A and B. This is measured using the voltmeter. How to measure potential difference? The instrument voltmeter we have to measure potential difference. The current high arriving at A divides into three branches, okay. Different current flowing through in each branch. One is I1, I2 and I3 passing through R1, R2, R3 respectively. According to the Ohm's law, you have I1 is equal to V by R1, that you take first equation, and I2 is equal to V by R2, I3 is equal to V by R3. The total current through the circuit is given by I is equal to I1 plus I2 plus I3. Using equation this 3, we will get I is equal to V by R1 plus V by R2 plus V by R3. Okay, let the effective resistance of the parallel combination of resistors be Rp. Then I is equal to V by Rp. Why we are taking Rp? It is a parallel resistor. Okay, so combining equation 4.16 and 4.17, you have V by Rp is equal to V by R1 plus V by R2 plus V by R3. Then finally we'll get 1 by Rp is equal to 1 by R1 plus R2 plus 1 by R3. Then we know that 1 by Rp is equal to 1 by R plus 1 by R plus 1 by R, and finally we'll get N by R. So Rp is equal to R by N. Here N is the resistors of equal resistance R are connected in parallel. The equivalent resistance is R by N. So the equivalent resistance in a parallel combination is less than the lowest of the individual resistance. When a number of resistors are connected in parallel, the sum of the reciprocals of the individual resistance is equal to the reciprocal of effective or equivalent resistance. Difference between series and parallel circuit. Criteria: series, parallel. Equivalent resistance. In series, more than the highest resistance. In parallel, less than the lowest resistance. Amount of current. Current is less as effective resistance is more. Current is more as effective resistance is less in parallel. Switching on and off. If one appliance is disconnected in series connection, others also do not work. But in parallel connection, if one appliance is disconnected, others will work independently. Have you ever touched the motor casing of a fan? which has been used for a few hours continuously, what do you observe? The motor casing is warm, right? This is due to the heating effect of current. The same can be observed by touching the bulb, which was used for a long duration. For continuous drawing of current, the source has to continuously spend its energy. A part of the energy from the source can be converted into useful work and the rest will be converted into heat energy. Thus, the passage of electric current through a wire results in the production of heat. This phenomena is called heating effect of current. This heating effect of current is used in devices like electric heater, electric iron, etc. Joule's law of heating. Let I be the current flowing through a resistor of resistance R and V be the potential difference across the resistor. The charge flowing through the circuit for a time interval T is Q. The work done in moving the charge Q across the ends of resistor with a potential difference of V is VQ. This energy spent by the source gets dissipated in the resistor as heat. Thus, the heat produced in the resistor is H is equal to W, that is work done, and is equal to VQ. We can take this VQ, H is equal to W is equal to VQ as equation number 1. So relation between the charge and current is Q is equal to IT, that we know already. This charge you have to substitute in the equation number 1. What is the equation number 1? H is equal to W is equal to VQ. Okay, in that you have to substitute this relation between charge and current. Okay, then we will get H is equal to VIT. This one you take it as equation number 2. From Ohm's law, V is equal to IR. Okay, we already know V is equal to IR is Ohm's law. This one we have to substitute in the equation number 2. Then we will get H is equal to I into R into T. So we can write this as 2I is there. So we can write it as I square RT. This is what Joule's law of heating. So, Joule's law of heating states that the heat produced in any resistor is, first one, directly proportional to the square root of current passing through the resistor. So, when this happening, when the resistance and time is constant, the heat is what? Directly proportional to the square root of current passing through the resistor. And next one, heat is directly proportional to the resistance of the resistors. So here I and T is constants. I is current and T is what? T is time interval. Here third one is heat is directly proportional to the time for which the current is passing through the resistor. Here current and resistor is what? Constant. So Joule's law of heating states that when a current I passes through a conductor of resistance R for time t, then the heat developed in the conductor is equal to the product of the square of the current and resistance and time. Application of heating effect. Electric heating device. The heating effect of electric current is used in many home appliances such as electric iron, electric toaster, electric oven, electric heater, geyser, etc. In these appliances, nichrome, which is an alloy of nickel and chromium, is used as the heating element. Why? Because it has high resistivity, it has a high melting point, and it is not easily oxidized. Dear children, do you know why we are connecting a fuse wire in your home? This fuse wire is connected in series in an electric circuit. When a large current passes through the circuit, the fuse wire melts due to Joule's heating effect, and hence the circuit gets disconnected. Therefore, the circuit and electric appliances are saved from any damage. This fuse wire is made up of a material whose melting point is relatively low. Filament in bulbs. In electric bulbs, a small wire is used known as filament. The filament is made up of a material whose melting point is very high. When current passes through this wire, heat is produced in the filament. When the filament is heated, it glows and gives out light. Tungsten is the commonly used material to make the filament in bulbs. Now solve problem 6. An electric heater of resistance 5 ohm is connected to an electric source. If a current of 6 ampere flows through the heater, then find the amount of heat produced in 5 minutes. Okay, here an electric heater, its resistance is what? 5 ohm. Always resistance is measured in a unit ohm. Okay, this is connected to a electric source. Okay, if a current of 6 ampere flows through the heater, okay, so now the current is what? 6 ampere. Okay, that 6 ampere of current is flows through the heater. So now what do you want to find? Find the amount of heat produced. So when the current is flows, 6 ampere of current flows through the heater, there will be a what? Heat. Okay, there will produce a heat. So the amount of heat produced in 5 minutes, that we want to find. Okay, what we want to find? Amount of heat produced in 5 minutes when the 6 ampere of current flows through the heater. Okay, so solution, given resistance is what? 5 ohm. R is equal to 5 ohm. Current I is equal to what? 6 ampere is given. Okay, and then time t is equal to 5 minutes, but we want to convert this time into seconds. So for 1 second is what? 1 minute is equal to 60 seconds. So 5 minutes is equal to what? 5 into 60 seconds, 300 seconds will get. Okay, next, amount of heat produced. Okay, we already know that Joule's law of heating, that is the formula to find the amount of heat produced in the heater. Okay, so H is equal to I square RT is the Joule's law of heating. So what is the I is the current 6, so I square 6 square into what is the resistance, that is 5 ohm, 5 into what is the time, that we converted 5 minutes into seconds, that is 300 seconds. So substitute these all the values and multiply, we will get finally 54,000 joule. So amount of heat produced in 5 minutes is what? H is equal to 54,000 joule. In general, power is defined as the rate of doing work or rate of spending energy. Similarly, the electric power is defined as the rate of consumption of electrical energy. It represents the rate at which the electrical energy is converted into some other form of energy. So, rate at which electric energy dissipated or consumed in an electric circuit. Here, dissipated means it's scattering in various direction wastefully. Okay, it is denoted by P. Okay, power is denoted by P. SI unit of power is what? Watt. It is denoted as W. Power consumed by a device carrying 1 ampere of current when operated at a potential difference of 1 volt. So the work done to move the charge across the ends of conductor is given below. So W is equal to V I into T. Okay, W is the work done and V is the watt potential difference. I is the power consumed by the device carrying conductor. T is the time. So power P is equal to what you will get, work done by time. What is work done? VIT by T. Okay, so the T get cancelled, so that final value you will get that P is equal to VI. That is the formula for electric power. Thus the electric power is the product of the electric current and potential difference due to which the current passes in a circuit. Consumption of electrical energy. Electricity is consumed both in houses and industries. Consumption of electricity is based on two factors. One is amount of electric power and another one is duration of usage. Electrical energy consumed is taken as the product of electric power and time of usage. For example, if 100 watt of electric power is consumed for 2 hours, then the power consumed is 100 into 2 is equal to 200 watt hour. Consumption of electrical energy is measured and expressed in watt hour, though its SI unit is watt second. In practice, a larger unit of electrical energy is needed. This larger unit is kilowatt hour. 1 kilowatt hour is otherwise known as 1 unit of electrical energy. 1 kilowatt hour means that an electric power of 1000 watt has been utilized for an hour. Hence, 1 kilowatt hour is equal to 1000 watt hour is equal to 1000 into for 1 hour. How many minutes? 60 minutes. So 60, and for 1 minute is equal to 60 seconds. So 60 into 60. Finally, we'll get 3.6 into 10 to the power 6 joule. Now, domestic electric circuits. First, electric power is generated by electric power station. They supply electricity to our homes through electric poles or underground cables. Electric wires reached our home through main supply. Here it has live wire and neutral. This live wire, it is a red color insulation. It is called live wire or positive. Next, neutral, it is of black color insulation. It is of neutral wire or negative. In our homes, electricity is distributed through the domestic electric circuits wired by electricians. The first stage of the domestic circuit is to bring the power supply to the main box from a distribution panel such as a transformer. The important components of the main box are a fuse box and a meter. The meter is used to record the consumption of electrical energy. Fuse box contains either a fuse wire or a miniature circuit breaker. The function of the fuse wire or a MCB is to protect the household electrical appliances from overloading due to excess current. The electricity supplied to your house is actually an alternating current having an electric potential of 220 volt. Both the live wire and the neutral wire enter into a box where the main fuse is connected with the live wire. After the electricity meter, these wires enter into the main switch, which is used to discontinue the electricity supply whenever required. After the main switch, these wires are connected to live wires of two separate circuits. These two circuits are 15 ampere current rating circuits and 5 ampere current rating circuits. 15 ampere current rating circuits, which is used to run the electric appliance with a high power rating such as air conditioner, refrigerator, electric ions geyser. 5 ampere current rating circuits, which is used to run the electric appliance with a lower power rating such as tube lights, bulb, TV, fans, etc. What is earthing? Why it is used? In domestic circuits, a third wire called the earth wire having green insulation. Its one end of earth wire is buried in the earth and the other end is connected to the metal casing of electrical appliances by using 3-pin plugs. This wire has green color insulation. This wire provides a low resistance path to the electric current. The earth wire sends the current from the body of the appliance to the earth. Whenever a live wire accidentally touches the body of metallic electric appliance. Thus, the earth wire serves as a protective conductor which saves us from electric shocks. What is overload? If too many electric appliances are used simultaneously together or too many electric appliances are connected to the same socket, they draw extremely larger current from circuit. Due to this, the wire may get overload and fire may start. This is called overloading. What is short circuit? When live wire and neutral wire comes in direct contact with each other, they cause short circuits. Due to high current passing through wire may get heated up and may catch fire. How to prevent short circuit and overload? It is prevented by using fuse. What is fuse and why it is used? Fuse is a device which is used in a circuit to prevent damages to the appliance and the circuit due to overloading. This fuse stops the flow of unduly high electric current. And next is MCB. MCB is a switching device which can be activated automatically as well as manually. It has a spring attached to the switch which is attracted by an electromagnet when an excess current passes through the circuit. LED bulb. LED is a light emitting diodes is an electric device that allows current to go in one way. LED uses a special material called semiconductor, example silicon. Semiconductors only allow the current to flow in one direction. The color of the emitted light will depend on the type of materials used with the help of chemical compounds like gallium arsenide and gallium phosphide. The manufacturer can produce LED bulbs that radiates red, green, yellow and orange colors. Displays in digital watches and calculators, traffic signals, street lights, decorative lights, etc. are some examples of the uses of LEDs. 7 segment display. A 7 segment display is the display device used to give an output in the form of numbers or text. It is used in digital meters, digital clocks, microwave ovens, etc. It consists of 7 segments of LEDs in the form of the digit 8. These 7 LEDs are named as A, B, C, D, E, F and G. An extra 8th LED is used to display a dot. Merits of LED. As there is no filament, there is no loss of energy in the form of heat. It is cooler than the incandescent bulb. In comparison with the fluorescent light, the LED bulbs have significantly low power requirement. It is not harmful to the environment. A wide range of colors is possible here. It is cost efficient and energy efficient. Mercury and other toxic materials are not required. LED television. LED television is one of the most important applications of light emitting diodes. An LED TV is actually an LCD TV. LCD is liquid crystal display with LED display. LEDs emitting white light are used in monochrome black and white TV, red, green and blue RGB. LEDs are used in color television. The first LED television screen was developed by James P. Mitchell in 1977. It was a monochromatic display, but after about 3 decades, in 2009, Sony introduced the first commercial LED television. Advantages of LED television: it has brighter picture quality, it is thinner in size, it uses less power and consumes very less energy, its lifespan is more, and it is more reliable. Reliable means trustworthy. Thank you.